Hello, everyone, and welcome to my presentation. My name is Lubomir Dimitrov, and I'm a professor from the Technical University of Sofia. We did this work with Professor Yuri Rubtsov. Unfortunately, I cannot be with you today, and I'm going to present my work by using this video. The topic of our work is verification of the results of data harmonization in the system for generating proposals for the selection of electronic component-based products for the development of electronic equipment. This work is addressed to a significant and often overlooked problem in electronic design automation: the verification of data normalization in systems used for selecting electronic components-based products. In this slide, I summarize the essence of the paper. The research objective is optimal selection of electronic components-based ESB products for the development of electronic equipment. The problem lies in creating a software product, I may say, similar like SolidWorks or Solid Edge for mechanical engineers. This is a system for obtaining, collecting, and processing reliable and up-to-date information about elements and the optimal choice for the developing equipment. In doing so, we have to solve the following subtasks: collection of information from various sources, data normalization, verification of results, comparison of results of collected data, and selection of proper elements. During the development process, we face the following difficulties: differences in formats for information collected from different sources, information redundancy, the risk of losing current data due to differences in time of receiving information from different sources. And as a conclusion, we can formulate the following subjects for the report in the paper: increasing the efficiency of selecting elements for electronic equipment development, organizing data for minimized redundancy, concept of normal force, and reducing risk of data anomalies. In this slide, I present the terms and notations that I use in the paper and in my presentations. A database, we consider a series of logistics-related tables. Table attributes describe connections with other tables, and relationships between data. Functional dependencies, sometimes we name them as normal forms and F in the paper. Those are rules for designing records. Verification of results of data normalization allows us to make sure that the problem has been solved properly. Therefore, I may say that the purpose of the study is to develop methods in validating the results of data normalization, as well as recognizing and replacing significant fields in tables in order to improve the efficiency of database operation. And because we are going to talk about optimization and optimal choice, we have to define it as the optimal choice consists of developing methods for validating the results of data normalization, as well as recognizing and replacing significant fields in tables in order to improve database efficiency. Most practical works consider only the primary key and ignore the supplementary keys. This is done in the work. This slide describes the software and hardware research environment. The proposed system for verification was created by using SQL Server 2019 and SQL queries. By using PHP programming language, web applications of the system embedded in HTML have been developed. The JavaScript programming language is used for both client and server applications. It expands the capabilities of the system by using a large number of libraries and frameworks. At the same time, it has inconsistencies in browser support. Different browsers, JavaScript code differently. There are security issues on the client side. JavaScript code executed in the browser may be vulnerable to attacks. Additional optimization techniques has been applied to address the issue of latency due to the synchronization nature of PHP. The system uses a combination of different programming technologies. The optimal solution is based on PHP and JavaScript. The system operates online and offline access modes. This slide describes analysis, relationships, and functional dependencies. Several types and interactions between elements of the system are presented here in the forms of small diagrams. There are one-to-one interactions, such as symbol for a product and the product itself. A chip can be different package as shown on the second diagram. There are some peculiarities for the placement of keys. They may vary depending on the type of case. Graphically, the degree of connections and is displayed by tree-like line. There are also other connections, such as connections of belonging. On this slide shows the existing main software tools for automated work for entity relationship modes. From the point of view of completeness of function, availability, and reasonable sufficiency, YED graph editor was chosen. This figure shows the proposed algorithm, the first part of it. On its base, a large model was built. It is presented on this and the following slides. The entire scheme does not fit on the slide, and it is not presented here. The enlarged model is presented in hierarchic form layout. It's a layout style that describes the priority relationships of orientated model element. It is suitable for database modeling for the purpose of the data normalization and allows to highlight the main directions of flow within the model. The second part of entity relationship model is presented over here. Cyclic dependencies of elements are automatically detected and links are provided. Elements are placed in hierarchically arranged layers. The order of the elements within the layer is chosen so that the number of the interactions of elements is minimal. Verification of normalization works at the model level of abstraction is presented. The choice of attributes for normalizations allows to carry out the procedure verification and eliminate weaknesses in the design of the system database. This is the third part of the entity relationship model. The verification procedure used a gradual change method for better identifying weak points and eliminates them using multiple enemy relationship diagram construction. The goal is to achieve the result of optimizing the system operation using the procedure methods. These procedure methods are of special type. First, the enlarged model is considered. Then the details are examined. The elements are controlled using the procedure and compared with the enlarged model. And finally, the conclusions that we make as a result of our works. The verification of results of data normalization, VREN procedure, plays a key role in the process of organization of database and maintaining its normal functioning. As a result of the work, a VRND procedure has been performed. So it has been determined that each type of input information about the electronic components base has its own characteristics in terms of VRDN. Positive value of VDNR application have been obtained by using active set of normal forms in terms of attribute equivalence classes in different levels of recording: first, second, third, voice code normal form, fourth, and fifth. The projectant joint form has been tested, but did not give an expected result for normalization, and it's not used, of course. An open questionnaire was developed, designed to collect position of information sources on the template structure. As a result of the analysis of the received questionnaires, templates were formed and types of information collection of the electronic components base were determined. Based on the templates and developed types of information collected, an analysis of relationship and functional dependencies were performed using entity relationship models. A tool for developing entity relationship models was defined. An enlarged data model, the hierarchical layout format was developed. The results show that the application of the VRDN procedure leads to data harmonization of the selection process of electronic component-based products for the development of electronic elements. And of course, a lot of work has to be done additionally. Those are the next steps that we plan to do. To model the overall design work and optimize by elements and by operating modes similar to P-space system. To create a complete system that will select electronic elements for the development of electronic equipment semi-automatically and in future automatically. This system will be self-learning system based on AI. It will search for sources. This means pulling out the right information from documents that are not in the right format. For example, making the necessary tables and documents in the format of PDF files. And finally, thank you for your attention. For contacts and questions over there is my email address. Thank you very much again.